Okay, this is BMIS 270, and we're talking about entity relationship diagrams. This is chapter 3. So, an entity relationship diagram is a data model that uses basic graphic symbols to show the organization of and relationships between data. So, what we're trying to do is get a picture of what what this data should look like. Okay, so first, an entity is a general class of people, place, or thing for which data is collected, stored, and maintained. Now, an attribute is a characteristic of an entity, and a data item is a specific value of an attribute. So, what we have in the picture is an entity is a vehicle, for instance. An entity is a part. Okay, also an entity might be a student, a faculty member, or a course. Okay, now for a student, an attribute, which is a characteristic of an entity, that might be your address. That might be your student ID number. And then that data item is the actual value of that number. In this case, what we have is a picture of some data. We have an entity relationship diagram which shows our relationships of one entity being vehicle to a model. Okay, now we have a vehicle as an entity and a part is another entity. So in this case, the straight line indicates at least one vehicle. Now the two crosses on that line indicate indicate only one vehicle. Okay, it's one and only one. Now the little tree, the crow's foot, means many. Can be one or many. Now the little zero here says at least can be 0 or 1 or many. So let's take a look at this and just think about it. We have to take a look, or we have to ask ourselves a question from the vehicle to the part, and then from the part to the vehicle in order to establish the relationship. So one vehicle can have one part. Well, that's true. One vehicle can have many parts. That's true. Okay, so one part can be on one vehicle. That's true. Many parts can be on one vehicle. That's true as well. Many parts cannot necessarily be on one vehicle because that relationship says just one. So many parts cannot be on many vehicles because of this relationship. Okay. So just think about that within inventory. Okay, now the next slide has a couple of examples. Example 1 and comically example 1. Now, so you have a manager that supervises, one manager, because that's the single line, supervises one or many departments. Okay, so that's fine. Now many departments, one department has one manager. Many departments have one manager. Now departments perform projects. So one department can perform one project as in the center line. One department can perform many projects. So looking at it from the other direction, one project can be performed by one department and many projects can be performed by one department. Now, we have the same situation on the right side. One salesperson serves many customers. One customer places many orders. Now, this is the situation where we get into some difficulties. Now, although this is shown with an associative entity, in truth, what this would have looked like initially is many orders with a little crow's foot can have many products. So think about it. One order can have one product. One order can have many products. One product can be on one order. One product or many products can be on many orders. So what you have to do in the middle of this is put an associative entity in here. You cannot have a many-to-many relationship. If you do and you try to query your database, you'll get Cartesian products, which means tons and tons of unnecessary outputs. Okay, so what you have to do is create a relationship where you have one order can be on many order lines or order items, and many order items inventory products can be equal to one product. Let's look at that a little bit differently. This is a line item receipt. This is something you get in the store. This is your line item. So one order can have at least one line item or item on it, right? Okay, one order can have many items on it. That's good. That's good. Looking at it from this side, one product can be on one line item. Okay, so you can buy just one thing on one order. Or one product can be on many line items. So that's a little bit confusing to begin with, and it takes really a lot of thinking about to really develop this associative entity. But what the real deal is that with this particular ERD, you're figuring out how you have to develop your database. So that is the real deal. Now I have a video I want to play, and hopefully I'll get it right this time. I'm going to turn off the audio output and still get the video or the audio input. So hopefully this will work okay.
Welcome to this video learning session. When you complete the session, you will be able to create entity relationship diagrams, also called ERDs. In this session, you'll learn what are ERDs and why are they important, how to create ERDs, and how to use a case tool to create ERDs. An ERD is a graphical model that shows how entities are joined together to form a relational database. You'll learn more about relational databases in other learning sessions. Let's view some examples of relationships between entities. The relationship between zip code and area is 1-to-1. One zip code identifies one specific area. The relationship between team and player is 1-to-many. One team can have many players, but a player only plays for one team at a time. The relationship between person and project is many-to-many. One person can be assigned to many projects, and each project can have many people assigned to it. You can draw an ERD freehand or use software tools. In these examples, we'll show entities as rectangles and relationships as diamond shapes. In a 1-to-1 relationship, one office manager heads one office. One vehicle ID number is assigned to one vehicle, and one social security number is assigned to one person. In a 1-to-many relationship, one individual can own many automobiles. One customer can place many orders, and one faculty advisor can advise many students. In a many-to-many relationship, one entity can match many instances of the other entity. For example, one student can enroll in many classes, and one class can have many students. One passenger can reserve a seat on many flights, and one flight can have many passengers. One order can list many products, and one product can be included in many different orders. In a many-to-many relationship, the entities must be joined by another entity, called an associative entity, which identifies and describes that particular combination. For example, a registration stores information about a specific student in a specific class. A reservation stores information about a specific passenger on a specific flight. And an order line stores information about a specific product in a specific order. Suppose you have a sales system where one sales rep serves many customers. One customer can place many orders, and one warehouse stores many products. These are 1-to-many relationships. However, order and product have a many-to-many relationship because one order can have many products, and one product can appear in many orders. So, we need an associative entity called order line that identifies a specific product in a specific order and stores information about that particular combination. Here's how the sales system might look in Microsoft Access. Notice the associative entity, order line, that joins the order entity and the product entity and stores information such as the quantity ordered. In Part 3, you'll learn how to use a case tool.
Okay, so that covers Part 2, specifically Part 2 of Chapter 3 and BMIS 270 covers entity relationship diagrams, kind of what they are, why we use them, and hopefully that'll be helpful. So thank you. Okay, you're good.